minus inverse sine of A. That was me trying to continue what I was saying in part 3 as I got cut off. Alright, let's now try question 4 from exercise 6K. This question is trying to see if we understand how to use the general solution to find specific solutions. It says, given that a trigonometric equation has a general solution x equals n pi plus negative 1 to the power n inverse sine of 1/2, where n is an integer, find the solutions of the equation in the interval negative 2 pi to 2 pi. Now, we didn't get given the equation, we only get given the solution, so someone else has done the work for us and given us this general solution to some equation. Actually, as it turns out, the equation would be sine of x equals 1/2. This is a little bit different, the way that they've presented the general solution to the way we learnt it. However, it still works, and you might like to think about why it works. It says n pi plus negative 1 to the power n inverse sine of 1/2. I'll leave that for you to try and think about. Post a comment if you think you can explain how this gives you the same general solution as x equals 2n pi minus inverse sine of 1/2 and 2n plus 1 pi minus inverse sine of 1/2. Why does this also give you the same solutions? Now, let's look at this interval here from negative 2 pi to 2 pi. Well, let's set up the general solution here, and we're going to try and figure out what our solutions between negative 2 pi and 2 pi will be. Well, our first solution will be when n is 0. So let's try and see what that is. X will give us two solutions actually. X equals 0 pi, which is 0, plus negative 1 to the power n. N is 0, so negative 1 to the power 0 is 1. And then we go inverse sine of 1/2. Actually, it's giving us just one solution there in this form of the general solution. Inverse sine of 1/2 we already know to be pi on 6. We've done that in previous videos. Pi on 6, not that, this one. That's one solution from negative 2 pi to 2 pi. Now let's try n being positive 1. We'll get pi plus negative 1 to the power 1, which is negative 1, times inverse sine of 1/2. Now inverse sine of 1/2 we know is pi on 6. So really it boils down to being pi minus 1 times pi on 6. So pi minus pi on 6. I hope you're following. Pause, rewatch if you ever get stuck in these and not following. So it's pi minus pi on 6 is our second solution, which I happen to know is 5 pi over, let's try this better, 5 pi over 6. That's our next solution. We still aren't yet at 2 pi. And we haven't even done the negative solutions yet either. Let's keep going. So n is 2 now. 2 pi plus negative 1 to the power 2. 2 pi plus negative 1 to the power 2 times inverse sine of 1/2. So that's 2 pi, negative 1 to the power 2 is positive 1. So 2 pi plus pi on 6, because 1 times inverse sine of 1/2 gives us pi on 6. 2 pi plus pi on 6, is that in our bounds? It gives us 13 pi on 6 if I'm doing that right in my head. Nonetheless, it's clear that it's above 2 pi, so that's not going to be useful. So we've gone too far now with our n. Those are the only two solutions from 0 to 2 pi. That makes sense if you looked at the unit circle, or the circle, and you thought about where the two solutions between 0 and 2 pi would be. Now, let's now look at the negative 2 pi to 0 solutions. Let's choose n as negative 1 now. So negative 1 pi plus negative 1 to the power negative 1. Negative 1 to the power of negative 1 is, well, it's 1 over negative 1 to the power positive 1. So that's 1 over negative 1, which is